Hello, Algebra 2 folks, and welcome to 7.3. We're going to continue to talk about E and how that is important when we talk about natural logs. So what we know is you need your notes, a pen or a pencil, and a calculator. So when we talk about logs, we have spent a lot of time talking about common logs. Common logs have a base 10. That's the log button on your calculator. And all calculators have a base 10, okay? Now, in order to use your calculator with other bases, you would use the change of base formula. So our calculator is set for base 10, okay? And what's so important about logs? Well, the importance behind logs is that they help us isolate the exponent, remember? So without logs, we really wouldn't be able to find the x value in our exponent, okay? So now what you need to know is that there is another log, and that log is called a natural log. And natural logs have a base e. So what you should know is that if I took a common log and made it a base e instead of base 10, I now have what's called ln, the natural log, log natural. I'm not sure why the L is before the N, but anyway, so you can find this button on your calculator. Most scientific calculators have not only a log button that we know is base 10, but we have an ln button, which is basically log with the e base, okay? And remember, e was Euler's number, which was approximately 2.72. Okay, that's what we remember about e from yesterday. All right, now using these two special logs, we're going to concentrate mostly today on natural logs. Now, how are they different? They're really not much different other than the base is different, okay? So now instead of working with base 10, we're going to be working with a base of 2.72 approximately. So here's an example. So I want you to take out your calculator and I want you to tell me what the ln of 6 is approximately. Well, it's approximately 1.79. Well, what does that mean? Well, another way to write ln is log base e. Well, how do I take a log and rewrite it in exponential form? Well, really what it means is that it's e to the 1.79 is approximately 6. Okay? So that's what it means. ln, instead of writing ln, we could write log base e, or instead of writing log base e, we just shorten it by using ln. Okay? But everything that we do with base e is the same as when we were working with all other logs, with all the different bases. All right, so natural logs and working with e, we've done rewriting in log form, we've done rewriting in exponential, same thing, but now instead of writing log base e of 54.6 is approximately 4, we're going to say, well, it's ln of 54.6 is approximately 4. So I'll never write log base e. I will write ln, okay? And then if I have an ln, I should know that that means the same as log base e. And truly, if you know that, we work with ln's, natural logs, and common logs the exact same way. So this would be e to the 1.079 is approximately 12. because I know ln means log base e. Or if I know log base e means ln. Okay? That is truly the only difference between what we've done last week working with logs and what we're doing this week working with natural logs. The e is called a natural log. So let's evaluate natural logs without a calculator. Our first step is always to rewrite it in exponential form. Well, we know natural log is the same as log base e. So this would be e to what equals 1. Well, anything to the 0 power is 1. So this would be 0. Okay? ln of e. Well, ln is the same thing as log base e of e equals rectangle, or we don't know. So this would be e to what is equal to e? Well, e by itself has an exponent of 1. So I would think that the only way that these two could be the same is this has an exponent of 1. So e to the power of 1 is equal to e. Okay, so ln again is log base e. E to the what is going to equal e squared. Well, and for both of these sides to be equal, this would have to be a 2. So natural log, or the ln of e squared would be 2. The natural log of e to the negative third, or ln of e to the negative third, is the same thing as log base e. E to the negative third equals what? E to what would equal e to the negative third? Well, in order for both of these to be the same, it would have to be negative 3. Okay, so knowing that ln is the same as saying log base e, we can do the exact same thing we have been working with. All right, what else can we do with logs besides rewrite them back and forth from exponential form back to log form? We can also graph them. So if we can graph common logs and logs with different bases, then I think we should probably be able to graph a natural log. So remember, f of x means y, and remember I always bring that over to this side. The other thing you should know is that ln means log base e. And now that I have those two things taken care of, I can rewrite this in exponential form. So e to the y is equal to x plus 1. E to the y, and I'm going to subtract 1, will equal x. Well, guess what? This is a lot like the logs that we graphed last week. Again, this is our asymptote, okay? And remember, because we're solving for x, our asymptote is x equals negative 1. So it's a vertical asymptote this time. Okay, and now that y is in the exponent, remember, now y becomes our negative 2 to 2. So our domain is x such that x is greater than negative 1. Okay, and our range is y such that y is equal to all reals. Okay, so our y is the all reals. So when I plug this into my calculator, e to the negative 2 minus 1, I will get negative 0.86. And if I plug negative 1 in there, I'll get negative 0.63. And if I plug 0 in there, I will get 1 and 1. Okay, if I plug 0, e to the 0 would be 1. And I subtract 1, I'm going to get 0. E to the 1, subtract 1, and I'm going to get 1.7. And e to the 2, subtract 1, and I'm going to get 6.4. Okay, and so then when I plot that, negative 8.6, negative 0.86, negative 2 is about right there. Negative 0.63, negative 1 is about right there. 0, 0, 1.7 and 1, and 6.4 and 2. Oops, I'm off a little bit on that one. Sorry, I'll erase that little dot. Okay, and now what this looks like is it looks just like a log graph, right? So it's going to get closer to the asymptote, but never touch it, and all those values are greater than negative 1. All right, so we can use base E. When we use base E, we call it a natural log, and we can convert it from log form to exponential form, and we can graph them. Thank you for taking good notes, and we will begin practicing more of these tomorrow.